Hi, here we have AP calculus basic problem. That is, we have to evaluate the given limit. Okay, to evaluate the given limit, I'm going to substitute the limit of x, that is pi over 2 for x, into the given function. So directly I'm going to plug in the given limit for x into the function. Then I'll be getting ln of sine. So for this x, we have to plug in pi over 2. So ln of sine pi over 2 over pi negative 2 times x, that is 2 times pi over 2 the whole square. Okay, this 2 and 2 will cancel out. So I get ln of, so the value of sine pi over 2 is 1. That is sine 90 degrees is 1 over pi negative pi the whole square. Okay, here we know that the logarithm, natural logarithm, here we have natural logarithm or any logarithm with argument 1 equals to 0. I mean, the value of log 1 is 0. And here pi negative pi is 0. 0 square is 0. So 0 over 0 is called indeterminate form. Okay, so when we evaluate a particular limit, if we get indeterminate form, so we have to use L'Hopital rule. So let's use L'Hopital's rule. So L'Hopital rule means we have to consider the step which comes right before where we have applied the limit. So this is a step I have applied the given limit. So you have to consider the step which is right before it. That's nothing but the question. So now I am taking the question. I write the given limit as it is. Now using L'Hopital rule means you have to find the derivative of the numerator and denominator with respect to the variable for which we have the limit. So here we find variable in both numerator and denominator. Usually, when we find derivative of a function where we find variable in both numerator and denominator, we'll be using coefficient rule of derivative. But when we use L'Hopital's rule, we are not supposed to use coefficient rule. We have to find the derivative of the numerator and denominator separately. Okay, when I find derivative of ln of sin x, it will be 1 over sin x. So far, I have completed derivative only for the natural logarithm. By chain rule, I have to do further derivative for the argument of the logarithm, that is sin x. The derivative of sin x with respect to x is cosine x over. And now I have to find the derivative of this stuff. So for that, first I have to find the derivative of the exponent. Then it will be 2 times pi negative 2x whole to the power 2 minus 1. So 2 minus 1 is just 1. So whenever the exponent is 1, we don't have to mention. So far, I have done derivative only for this exponent 2. By chain rule, I have to do further derivative for the base. So pi is a constant. When I find derivative for this pi, it will become 0. When I find derivative for this negative 2x, it will just become negative 2. Because negative 2x means, so we have to keep the constant as it is. The derivative of x is just 1. 1 times negative 2 is negative 2. And this pi will become 0 when I find the derivative because it's a constant. Okay, here, so 1 over sin x times cosine x, it will become, limit extends to pi over 2. So it will become what? Cosine x over sin x. So by using coefficient identities in trigonometry, cosine x over sin x equals to what? Cotangent x over 2 times negative 2 will be negative 4 times pi negative 2x. Okay, so that's all the simplification we can do. Now we can apply the given limit, that is pi over 2 for x. When I do it, so I'll be getting cotangent pi over 2 over negative 4 times pi negative 2 times pi over 2. This 2 will cancel out. Okay, so already we know that, so we have to get the value of cotangent pi over 2. Cotangent is a reciprocal of tangent. So already we know the value of tangent pi over 2. What is the value of tangent pi over 2? Tangent pi over 2 is undefined. Tan 90 degrees is undefined. Then cotangent pi over 2 is equal to 1 over tangent pi over 2. Then 1 over undefined, that is infinity. Whenever you divide a number by infinity, that results 0. So the value of cotangent pi over 2 is 0 over. So here pi negative pi is 0. 0 times anything, 0. Again, we get indeterminate form. Okay, so I have already used L'Hopital's rule, but I get indeterminate form. So again, I have to use L'Hopital rule. But so you have to use L'Hopital rule usually in the step that comes right before the step where I apply the limit. So here, this is a step I have applied the limit pi over 2. So if you want to use L'Hopital rule, you have to use the previous step. So this is a step. I have to use L'Hopital rule again. Okay, let me continue this on the next page. So again, I'm going to use L'Hopital's rule. The limit extends to pi over 2. So here, so this is a step, I apply the limit. You just consider this particular step. You have to apply L'Hopital's rule over here. That means you have to find the derivative of the numerator and denominator separately. When I find the derivative of this numerator cotangent x, that is negative cosecant square x, the derivative of cotangent x is. And in denominator, we have negative 4 is multiplied by the variable part. So you have to keep this negative 4 as it is and find the derivative of this one. So negative 4 times. So when I find the derivative of this pi, it will become 0. The derivative of negative 2x is just negative 2. So limit extends to pi over 2 negative cosecant square x over negative times negative will become positive. 4 times 2 is 8. Okay, so the next step, so that's all the simplification we can do. Now we can substitute the given limit pi over 2 for x into this one. So negative cosecant square pi over 2 over 8. So cosecant square pi over, 1 second, let me evaluate the value of cosecant square pi over 2. So cosecant cosecant is a reciprocal of sine. So if I want to get cosecant square pi over 2, it can be written as 1 over sine square pi over 2. What is the value of sine pi over 2? It's just 1. Since we have sine square, we have to take 1 square. So 1 over 1 square. 1 square is 1. 1 over 1 is finally 1. So finally, the value of this cosecant square pi over 2 is just 1. But there is a negative sign in front of it. So we have to take negative 1 over 8. So the evaluation of the given limit is negative 1 over 8.